gets translated to a protein. So we left off last time with designing this function called factorial that computes 1 times 2 times 3 times 4 all the way up to n. So n times n going the other direction, n times n minus 1 times n minus 2 all the way down to 1. And we immediately identified a few problems here. Even though 5 and 6 worked, right? 120, that's pretty straightforward. 6 would be 720. We identified two main problems here, that if we go up too high, say 20, then we get negative values. What are those negative values coming from? Overflow. An integer is only going to hold 32-bit signed integer, so it's only going to hold values up to 2.147 billion or something like that. It also holds negative values. There are no unsigned values in Java. So what we could do is we could go ahead and increase the size here to a long, which is a 64-bit integer. Change that one, and change that one. This should still work. 20, now we can actually get an answer out of this. I assume that that's the factorial of 20, but that only bought us a few more bits, and it bought us 32 more bits, right? So what if I went with 30 factorial? I would still hit the same problem, that eventually I'm going to have overflow, something that is larger than a 64-bit number can hold. So we did look at one solution before. Instead of an int, instead of a long, if you want an arbitrary precision, arbitrarily large number, what could we use instead? Big integer, right? A big integer will grow without bounds, right? And I just want to, it's not going to be that tough to change this. Big integer result is equal to new, actually if I want to start at 1, big integer dot 1, there's already 1 built in, also for 0, okay? Remember that this kind of takes us back to what we're examining here, that if I've got a class and then I've got members of that class, for example, a function in that class, I use the dot operator here. Many of you are familiar with this from last semester where you had structures, and then to access a member variable in that, you use the dot operator or the arrow operator. The arrow operator we don't have in Java because we don't have pointers in Java. So we are going to use the dot operator. That there's this class called big integer, and in that there is something called ONE, 1, to represent a big integer of 1. Now, I can't take a big integer and multiply it by a big integer with that asterisk. Instead, I'm going to have to use member methods on that class. So result dot it's kind of small, but you can see multiply, right? There is a multiply function, a multiply method that is part of that class. Just like down here, demo, well, inside demo, you have this method called factorial. So how do you call it? Demo.factorial. So result.multiply, and then we want to multiply it by I, right? And then put it back, the result back into the result over here. This is going to complain. If I hover on this, it's going to tell me that the method multiply long from the type big integer is not it's not visible. Oops. Dot. Let's see. Multiply. It needs another big integer. Excuse me. So what we're going to have to do is we're going to have to go big. I believe it's big integer dot value of, and then I can give it I. Right. But yet another example of, and now this is italicized, which matches this italicization down here. That's because they are both static methods. They belong to the class. We'll get into exactly the difference between a static method and a non-static method later on. For now, all of your methods can be static. Okay? We're not into object-oriented programming just yet. So this is a static method that I can call class. And if I've got other stuff in a math library, math.square root or math.sine or something like that. And this should work. And then I, of course, need to change the value, the type down here. And then I don't know that this will work. I'll print it as a string instead, though. And fact.toString. Oops. .toString. There we go. There's a toString method there that will take that big integer and dump it to this very, very long string. Everything taken care of now? It's complaining about something. Oh, thank you. There we go. All right, let's run it. And there, now I can hold 30 factorial. Right? Now, the ultimate question last time was, what was 100 factorial? That's going to be huge, right? It's that many digits, however many digits that is. Well, nothing's stopping me from doing, I don't know, 1,000,000 factorial, no overflow, but what's going to happen? It's taking a long time, right? It's only doing 1 million operations. Computers can do 1 million operations in the blink of an eye. It's still going, right? And by the way, how do you know it's still going? Well, there's nothing printed here yet, but there's this active stop button down here. If I wanted to stop it, I could stop it. It's doing all this in memory. It's doing all this in software. It's extremely inefficient. This is why we like 32-bit integers and we like 64-bit integers and floating point numbers, because it can all be done in hardware, and hardware is super fast. Software is super slow. I'm not even going to wait for it. We could at least do 1,000. 1,000 should be doable in a pretty quick. But of course, how many? There we go. There's a whole bunch of digits there, and I don't know how many it is. Right? Okay. This still has to be documented. All of your code, when you submit it, should be well documented. Now, documentation belongs with major portions. So, for example, a class should be documented. This is my demo class, right? But also, each major method should be documented. So I'll go ahead and document this. This method computes arbitrarily large factorial values, right? And because I'm using this slash star star and hitting enter, it's giving me all these nice this nice doc style comments that we've talked about before. This is Java doc style comments. For more information, let's look up the Wikipedia page on Factorial, right? Factorial Wikipedia page, right? Or there we go. That's what I looked up last time to explain it, right? See, and then I can embed HTML directly into this. Wikipedia, or pronounce that for me. Other people pronounce it differently. I don't know why. Wikipedia or something like that. Right. Okay, all right. It looks like Tiki to me, so I'm going to call it Wiki. All right, there we go. And if I hover over this, I get nicely formatted documentation. Right? And every one of your methods should have. I encourage you to do doc style commenting because it's the easiest. You just hit slash star star, hit enter, and it'll automatically format it for you. Right? Main methods probably don't have to be documented, but major portions of your code should. That includes possibly classes and methods. Now, if you've got a particularly complicated block of code within a method, you probably want to have inline documentation there. You would not put doc style comments there, though. You'd put single line comments. This is a loop, if you don't know. Right? That kind of documentation is not good documentation. Right? Anybody who knows Java or C or whatever programming language, they know that that's a loop. Right? Code should be self-documenting in that self-explanatory stuff that any coder that knows that language would understand. That does not need to be documented. Okay. Let's do one more since I've got it over here, and it involves mixing a couple of things here. Let's go ahead and make another public static double Euclidean distance. A Euclidean distance function, because this allows us to use other functions calling functions. What I'm going to do is I'm going to take 4 doubles, right? And normally it would be x1, y1, x2, y2, right? And this gets kind of long, right? So you can go ahead and break it apart on multiple lines here. It's not compiling here because they don't have a return statement yet. Return 0 for now, and it will stop complaining. But generally what you can do is you can go ahead and align this stuff. I like to align it so that everything is lined up like this. Some people like to align every single one, so something like this, and then, just load it all over. Whatever your style, as long as you're consistent about it. Now, if you don't like that style, then that's fine. You can use the built-in style. If you start screwing up, okay, well, I thought that was a good idea, but I don't like that anymore, or everything suddenly gets unaligned, remind me, what's the quick key to have the IDE fix it for me? Control Shift or Command Shift if I'm on a Mac here, so Command Shift and then F, and it'll take care of everything for me. The default styling here is just to go all to one line. Right? So be it. right? As long as you're consistent about it. Let's go ahead and make sure that we are documenting this. So /** enter automatically formats all that stuff for me, right? And I'll go ahead and say that this computes the Euclidean distance between the 2 points x1, y1, and x2, y2. There we go. And you can even mark this up a little bit. In my example here, I've got it marked up as code. Right? That's an HTML tag that will format it as literal code. Format that one and format that one. And you can kind of see that it looks kind of nice if you hover over this, that x1 and x1, that these values right here, you can't see it very well, but they are monotyped, so it looks like code. And you can embed code. You can use pretty much whatever HTML you want in here to format things nicely. You don't have to go overboard for your assignments and projects and stuff, but you should start getting in the habit of using doc-style comments. If you move over to another programming language like Python or C or whatever, you should adopt the de facto standard for commenting in those languages. Right? Just the other day, I was working on some Python stuff, and I thought finally, I need to document this because it's finally for some other people. I had to look up, because there's no doc-style comments in Python, what is the idiomatic way of documenting stuff in Python. And so I had to look that up, and it's done slightly a little bit differently. But how does that language do it? Right? And what is the standard for that language? You just have to start adopting those standards when you pick up a new language. Okay? What is the Euclidean distance? The Euclidean distance is the difference between the points. So if I've got point x1, y1 and point x2, y2, right? The distance between them is going to be, does anybody remember off the top of their head? Square root. So how do I get the square root? Math.sqrt. Right? So again, this is a class, then a dot operator, and then whatever function or a method that you want to call in that class. There's also not size, S-I-N, not S-I-N-E. There's absolute value. There's a whole bunch of floor, ceiling, round, et cetera, et cetera. So math.square root is what I want. Right? Well, wait a second. Java is a more modern programming language in that it's only 25 years old versus, say, C's 40 years old or whatever it happens to be. In C, we used SQRT because 40, 50 years ago, if you could save a few characters from your source code when you were measuring hard drive space in kilobytes rather than terabytes, right? That mattered back then. It doesn't matter anymore. It certainly didn't matter in 1995 or 1996. So why do we still use that weird abbreviation? Why not just square root? Right? That looks a lot better, I agree. But what's an argument in favor of using the old school way of doing this? It's faster to type. Not compatibility between languages, but the idea of compatibility of a programmer's brain. Right? It's familiar. Right? If one programming language does it and it influences 50 other programming languages, guess what? They all copy the good stuff. Whether or not this is good, I don't know, but it's familiar. That's why we use SIN instead of SINE. Right? It's familiar. It's from C, basically. Right? And it's going to be x1 minus x2 squared. Can I do that in Java? Nope. Some programming languages you can do that. Some programming languages you can do this. Java is not one of them. So how do I raise this to a power 2? Okay, I could use math.pow and raise the first one to the second argument. That'll work. And then, of course, I take the addition, right? Yeah, addition, and then of the y components here, y and y. Right? That's good enough, but if I didn't want to use the math library in that instance, I could just take x1 minus x2, multiply it with itself, right? Because squared, x squared is x times x. There's no need to use some interpolating method over here that does a bunch of complicated stuff under the hood. In fact, a good compiler would probably get rid of this and not do something like this. You're just raising it to power 2. I'll just use multiplication then. Right? And I can store that value into an intermediate result. Result is equal to this, and then return the result. result. Oops, double result. That's what I wanted to do. But, of course, if it's just a one-liner, why have a local variable here at all? Why not just return that value itself? Right? And we're good to go. Right? Well documented here. If I hover over, you can come and document each one of these things. The x component of the first point, right? The y component of the first point, the x and the y component of the second point. Here's some magic for you that we'll use later on. There we go. And the, oops, sorry, there we go. The x2 of the second point. There we go. What did I just do there? Did it seem like magic? Normally if you select something, I want to copy this thing and this thing together so that I could paste it down there. Right? Normally if you select something like this, that's line selection. I didn't want that first stuff there at all, though. I wanted what's called block selection. And unfortunately, you can't see it very well because it goes into this block selection mode. You can select blocks of text. You can also do cool things like, maybe parameter, right? You can, the cheating at the chalkboard, right? If you have to write something on the chalkboard over and over again, you go to the music room, and music teachers are cheaters too here. How do you write scales? Right? Do you write 1, 2, 3, 4, 5 lines for notes? I mean, right? What do? You have got that nice little thing there that has 5 pieces of chalk stuck to it, and then you drag it across the screen. Right? That's what block selection mode does for you. I won't do that because parameter. There we go. Right? It's a way of saving some time, right? Or if you've got, say, CSV data or columnar data, where you've got this column and this column and this column, I just want that column there. You could take it into Excel and then manipulate it that way. Otherwise, you could get yourself a nice IDE like this and use block selection mode. How do you get into it? Option Command A. Option Command A to get out of it. That's for Macs. For Windows, anybody out there help me? I think it's going to be Alt Control A. Try it. See if it works. Say what? Alt Shift A. Okay, thank you. Alt Shift A. All right, there's another one example. I'll make sure that this is the notes. I'll go ahead and cut and paste all of this stuff over here into the notes. The entire thing. All right, great. Before we go on, though, and get rid of this stuff, remember what the other issue was from last time. What is the factorial of -10? One? Is that right? No, it's kind of undefined, right? So I don't want to, I want to make sure that I am handling this correctly. What I'm going to do is I'm going to start using what are called exceptions. Now, if you're coming from a C background, the way that you do error handling is you look before you leap, right? Am I about to divide by 0? Am I about to call this function on a negative value, in which case or did I call this function on a negative value, in which case I need to return a special value, right? Something that would, it might look something like this. That's called defensive programming. If n is less than 0, and by the way, the factorial of 0 is defined. It is 1. That's the number of ways of arranging nothing. And how many ways are there of arranging nothing? One way, you do nothing, right? So if it's negative, then normally what I would do is I would return an error code in C, right? 1 or some non-zero value. But I can't do that in Java because I need my return value here. I don't have pass by reference in Java. I only have pass by value. So I can't do that kind of defensive and error code kind of error handling that we do in C. Instead, I'm going to check to see if n is 0. And then what I'm going to do is I'm going to throw an exception, a new exception, runtime exception, with the message. Factorial is undefined for negative values. There we go. So a runtime exception is kind of the opposite. So the defensive programming is looking before you leap. If you come across a precipice, a cliff or something, and you look to see if I take one more step, I'm going to fall off this cliff. Right? That's defensive programming. You look before you leap. With exceptions, go ahead. Go ahead and leap. Go ahead and do something dangerous, like calling this function here, because what we're going to do is we're going to maybe catch you if you fall, and then throw you back up. We'll talk about that in a second here. Let me go ahead and show you what this looks like. There, exception in main. Factorial is, there's our message. Factorial is undefined for negative values. You might have seen this already in some of your work. For example, what if you try to do the following? Int x is equal to, how do I parse out an integer again? Integer dot parse int, right? And 1, 2, 3, right? This should be perfectly fine. In fact, if I print this out system.out.println x, as long as I get rid of this. Let me change this back to 10 for now so that we can actually get down here and run this. There are 123. What happens if I give it something that's not an integer? Hello. Right? Is hello any integer you've ever heard of? So what's going to happen? Another exception. What kind of exception? A number format exception. What's the message? For input string hello, that's not a string, or that's not an integer that I can parse. So it throws this back at you. Okay. Well, how do I now maybe I do want to be a little bit defensive. Well, what's happened is I've tried something dangerous. It's thrown an exception. It's thrown an exception at me, and now I need to decide, do I want to handle that exception? And if so, how do I want to handle it? So what I'm going to do is I'm going to surround all of this stuff in a try and catch exception E. Right, there we go. So this is why it's in contrast to defensive programming, where you have to look before you leap. Go ahead and leap, right? Because if you fall off the cliff, don't worry, we'll catch you, right? And you won't die at the bottom. We'll catch you and put you back up on the cliff. And now you can decide how to handle the exception here. Right? Note that this code worked even without this try catch, because it was my choice. Do you want to handle the exception, or do you, like before, with all this red text here, do you want to let it be fatal? 9 times out of 10, you want your exceptions to be fatal, right? But there's that that 1 time out of 10 or 1 time out of 100 that maybe you want to do something different. For example, reread the input from the user. Right? You could do something like that. And I'm not going to do it because I put in a to-do, right? That classic lazy programmer here. If you know, okay, I need to eventually do that. I don't want to do that right now. I'm going to procrastinate. I'm going to do that later. Always put in a to-do to remind yourself. And in fact, it's great because eventually, I don't have it here. Let's see, restore view window, show view, tasks. There we go, tasks. I've got a lot of to-dos, right? That if you use that to-do style stuff, implement this, I actually do something here. Then what your IDE will do, it'll collect all these things. Now these are in other projects here. Where this project here, Hello World 2, there's the reread the input from the user. You can double click on it and okay, now that I've got some time and fine, I'm going to have to go back and do all the stuff that I said that I would do later. Now I can come back and start doing it. Right? One of the nice things about your IDE. Yeah?
Yeah, what is the exception E you put in the parameters?
Good question. E is whatever exception was thrown. So there could be potentially dangerous code here in 2 ways. One way is going to be that you are calling this function right here on a negative value. Another way would be that you are parsing something that is not an integer. Those are 2 different types of exceptions. One of them was a runtime exception, and this one was a number format exception. What you can do is you can catch those independently. You can catch a number format exception, call it NFE, right? And then to do reread the input from the user. Then if you want to catch a different type of exception, such as a runtime exception, RE, then you can handle this exception slightly differently. Right? It's kind of like an if-else-if statement. The first one of these things to match is the one that gets executed. The one I had before was a catch-all, right? If any other type of exception occurs, every type of exception is an exception, right? This is, okay, I don't know what happened. Let's rethrow it. Right? So throw a new runtime exception. And we'll go ahead and wrap up E in a nice little package here and rethrow it. And in that way, I'm making it be a fatal exception. If I'm rethrowing it in a catch block here, it means that I want the program to die because there's no way to recover from this, right? I have absolutely no idea what happened. I have no way, if I don't know what happened, that it was unanticipated, then I want it to be fatal and I want my program to end, right? You can also do things like, okay, well, let's log that stuff, e.print stack trace. That's what it was doing in the, oops, there we go. That's what it was doing down here in the console. That red text, it was printing the stack trace to the standard error, which is highlighted in red in my IDE. You can configure that, but the standard output is in black, right? Pretty straightforward. The standard input, I think, is in green, and the standard error is in red because something went wrong, right? So when I run this, let's run it again and see what happens. Oops. Well, nothing happened this time. Why? Because I called Factorial on a negative value. That threw a runtime exception. And did I handle it? No. I just said, OK, fine. I don't care. Move on, right? And normal execution went after this. System.out.println. OK. Right. And if I run this, you'll actually see the OK because an error occurred. It caught us. It put us back up on the cliff. And we were like, OK, whatever. And we started, and we continued walking somewhere else. Right? I decided not to handle that. Yeah?
Would it be viable to put in your attach handle to just throw the exception that you got?
Yep, that's what this does, basically. You can't throw E. You can't throw RE. I don't think you can. Yeah. Oh, you can. OK, you can do that. I usually don't do that because it's something I don't want to get into right now. Java has something very, very weird that was a stupid idea 25 years ago. In the 25 years since, everybody's realized it's a stupid idea and nobody's copied it since. There's a difference between exceptions. There's a checked exception and an unchecked exception. If you want to read all about this, go ahead and check out the CS1 book, Java on it. This is an unchecked exception, meaning the only difference is you have to surround it with a try-catch, or it's optional. Right? The optional part is good because it leaves you flexibility in your design. The checked exception that forces you to have a try-catch, we'll see one later today when we start doing file I/O. Right? But yeah, go ahead.
Yeah. So when you throw the new exception, it's not putting anything to console. What exactly does that do?
Throw RE. Well, I don't think was this.
The throw new runtime exception.
If I do this, then it'll print the stack trace.
Okay, so
right?
it wasn't there.
Yeah, it wasn't there. Well, because I didn't run it. I just said, well, you can do this, but I generally don't do that. I wrap it up in a unchecked exception so that it becomes optional. Right? We'll see how to handle that later on. Right? Okay. Yeah, go ahead.
ePrint stack trace is the same line of code as throw new runtime exception.
It depends. So rethrowing it is a little bit different because if higher up in the stack, you chose in the stack trace here, you chose not to catch it, you chose not to catch it, you chose not to catch it, you chose to catch it up here, but you printed it down here, then you'll get different behavior, right? In the stack trace. So function calls function calls function calls function, right? It all depends on where, I'm rethrowing it because if some other piece of code decides to go ahead and catch it, that's their business. It's just a way of error handling. We'll see. Again, 99% out of 100, you want your exceptions to be fatal. You don't want to continue computing stuff if you've got an error that you don't know how to deal with. Right? Okay. All right. Yeah, one more question?
Sorry, I'm just kind of...
Okay. Again, I don't generally do. I don't generally see or do it myself, but you can rethrow it. it'd be the same. It'd almost be equivalent in this case because they're runtime exceptions, unchecked exceptions. Again, don't worry about the difference. Okay. Just sometimes Eclipse will say have a compiler error that says you must. This is a checked exception. You have to handle it. Right. You don't have a choice. And so usually it's you have two options. You can rethrow it, kind of like I'm doing right here, or you can surround it with a try-catch. And surrounding it with a try-catch and rethrowing it is generally what you want to do. Right? But we'll see an example when we start doing file I/O here in 1 second. Right. Okay. Any questions? Okay. Yeah. Go ahead.
What exactly is triggering the catch right now? Because it should be running through.
So. Let's walk through. Oh, you know what? Here's another tool. I just put a little blue dot over here on the left-hand side. Right? There is a built-in debugger here that Emily posted a good video on, and you should start learning how to use. Instead of hitting play here, I'm going to hit this little. It's a bug, right? That opens up and launches the debugger. Right? So now what my program here is stalled on this line. Over here, we can look at whatever we were given as part of inputs, or stuff will be updated here as we go along. So, for example, if I step over this line, right, now I've got a variable that's in scope, n, and I can see its value over here. I can even highlight it and see it printed down here. But there's its value over here, -10. Right? So what exactly is triggering it? Well, let me go ahead and if I step over this, then it immediately jumps down there because this function through this exception. And so we caught it down here. I don't want to do that. Let's go ahead and start over. Instead of stepping over an entire line, we can step over a line. I want to step into, and that's this little guy over here. I step into. I want to step into that function to see what it looks like. So now it takes me to that function, and it starts processing. Well, what is n? Well, you can see it up here. It was -10. So step, right? And you can see, oh, well, it was -0. It was negative. So we get to this line, and it throws a runtime exception. Right? It was not a number format exception, so it skipped this block, and it went immediately to this block. Right? And I chose not to handle it, so what happens after that? It continues after to that line, right? And it prints OK. And that's the end of the program. It's not the end of the program here. If I step one more line, that's the end of the program. Right? So nice little debugger here that you can use, just like GDB last semester. Except with GDB, it was TUI, Text User Interface. This is a full IDE, Graphical User Interface, GUI, TUI, or whatever, if you want to pronounce them like that. And then you've got buttons instead of keys. Next, next, next. S for step, step, step. Set breakpoint. Well, you can go ahead and click over here. Let me go ahead and go back into my Java perspective. And you can set as many breakpoints as you want. Right? You can double click on them to get rid of them. Right? And you can run the debugger, go back to the other perspective, whatever you want. Okay? So nice debugger here. Most IDEs will have something like this. All right, so to review, error handling. Right. So in Java, let me get to my notes here. Java supports using exceptions for error handling. Right? An exception is an interruption of the normal flow of control. Right? Just like we saw that, oh, something occurred. You tried to parse something that wasn't an integer. That's an error. It throws an exception, right? Potentially dangerous code can be surrounded by a try-catch block, right? If an exception is thrown and you catch that type of exception, then you can handle it with any code you put in the catch block. Right? And again, I chose not to do anything. I chose to print it right here. I could have chosen to do reread the input from the user, or to do if this happens, then delete the hard drive. All right, there we go. All right. Something extreme. Right? We can't blow up the computer, at least from software we can't blow up the computer. But we can definitely delete the hard drive or reformat the hard drive. Format the hard drive. Right? I'll do that later, though. Right? Hopefully the operating system would prevent me from doing that. But so the syntax, the example, and I'll just make sure that this example over here is in the notes. There we go. There. So the example that we had here, okay, that we have a try. You can have as many catch blocks as you want, and then this is a catch-all block where you don't know what happened. We'll just go ahead and rethrow it, okay? All right. So as an let me go ahead and get rid of this stuff so we have a cleaner demo here. What I want to do is some file I/O now, right? File I/O. And this will actually connect to what we were just talking about here with exceptions. Let's go ahead and open a file and process it for input, right? So file input. Now remind me, in C, you've got three steps to doing this. You open the file, you process the file, and then you close it. What did we use to open the file in C? Fopen. What did we use to close it? Faclose. What did we use to process it? If it's an input file, I want to get that entire line over there. Forgets, right? So how do we do that in C or in Java? We have something very nice called a scanner. Right? A scanner will scan our input file instead. New scanner. Right? Now I need to tell it that there's this file on the system called, I don't know, new file. Input.txt, right? There we go. And now I'm going to have to hover over all this stuff and import it. There we go. There. Now immediately, this is correct code, but immediately it has a syntax error, or a compiler error here, right? There's no syntax error, it's a compiler error. And if you can't read that, it says unhandled exception type, file not found exception. And my two options are to surround it with add a throws declaration, which would look something like this. It would bring this throws up here, and now I'm just shifting the responsibility to somebody else. Anybody who calls main is now going to be forced to handle this file not found exception. Not a very good solution. So what was the second solution that it offered? Surround it with a try catch. Right? This is one of those other types of exceptions. The checked exception that I am forced to deal with. I am forced to surround it with a try catch. Right? So any anglers out there? People who go fishing? All right, you catch a fish and you already hit your limit, but you still want to go fishing. So what do you do with the fish if you can't keep it? You throw it back, right? You catch and, what is that called? Catch and release, right? So what I'm going to do is I caught it, I'm going to release it by rethrowing it. Throw new runtime exception E, right? And then get rid of this stuff. Get rid of the to-do because I handled that, right? I'm just going to make this into a fatal error. And in fact, you can see that it happens. There's no file called input.txt yet. I haven't created that file, okay? As you saw in Lab 1, if you're in an IDE, input-output files, they should probably be in some folder somewhere within your project. So I'm going to go ahead and create a folder. I'll just call it a data folder. And inside that folder, I'll create that file, input.txt. There we go. And I can go ahead and edit this. First line, second line, blank above, last line. There we go. I've got a 5-line input file here. Now, if I run this, it can open up the, it still doesn't find that file. Why? Is there any input file at the root of my project up here? Nope. It's in a directory called data. So I need to open up the correct file. I need to open up data/input.txt. Okay? And it will find this file now because it does exist. I just created it, right? And it has 5 lines in there. So that's opening the file. Open a file and process input for it, right? 2, I'll label these even. 1, open a file and process it for input. A scanner gives you input. I'm going to scan the input. So I can do a lot of things. Scan the input, get the first line. Right? String, first line, is equal to s dot. And now the s is my scanner. It's scanning that file. I have a lot of options here. I can get the next string in that file. I can get the next line in that file. I can get the next integer. Next int, or dot next int. Right? Yep, right there. Next int. So if I wanted to, I could like 123. Right? And then let's print that out. Let's see, and then system.out.println. It's going to end up reading that first line. I misnamed it first number, and then I'm going to have to change this one, first number. Okay, I'll show you a better way of doing that here in a second. Next int, oh, what are you complaining about? Oh, the int, there we go. And we can see that it's going to read that 123, that first one. What if I got the second number, and I printed out the second number? Is there a second number in there? 123, what's next? Well, an n-line character and then a string. So what's going to happen here? Read 123, print 123. Read next line or next the n-line character or whatever and try to treat it as an integer? What happened? Input mismatch exception, a different type of exception. You can surround this with a try catch, and that's exactly what I did here with the file not found exception. You can take and you can go ahead and catch a, what's it called here? Input mismatch exception, there we go, IME. And then I don't know how to deal with that, so I'll go ahead and throw a new runtime exception of bad file, man. All right. There we go. Input mismatch, I misspelled it. Or it's not imported. Okay, I didn't misspell it. I just have to import it. Come on, hover and import. There we go. And now I can see 123. Oh, bad file, man. Right? So you can do stuff like that. But if you want to process an entire file line by line and then worry about processing each line by itself, for example, CSV files in your first assignment here and in your project eventually later on. Let me go ahead and read it line by line. So scan the input, get each line, and process it. So I'm going to take all of this away. And I don't want to just read an integer. I want to read the entire line. String line is equal to s dot next line. That'll get the entire line, and I'll go ahead and print it out. System.out.println line. There we go. If I run this, then I get the first line. Right? If I did that a second time, I would get the second line. Line 2. And you can see where I'm going here. Is this the correct way of doing something like this? Line 1, line 2, line 3. And you can see that, well, 1, 2, 3, first line, and that's no longer the first line, but that's what it is in there. Then the second line. Should I continue like that? Probably not. I want to go into some sort of a loop. So remind me, when do you use a for? When is it? You can always use a for loop and a while loop interchangeably, but which is more appropriate in this case? I want to read the entire file line by line until I get to the end. While. Right? Because I don't know how many lines there are in the file up front. If I knew how many lines there were, it would be more appropriate to use a for loop. So while, and I'll go ahead and get rid of this stuff, while s dot has next line. Right? You can also use has next int, has next period, next string or whatever. Right? And while it has a line, go ahead and read that line and print it out. And now when I do this, I get every single line in that file. 1, 2, 3, first line, second line, even the blank line, and blank above and last line. Right? Note here that I am printing it with an n-line character. If I didn't do that, then it would all be on one line because scanner takes out that n-line character. It strips it. Okay? What if I wanted it to strip more? Instead of just printing it, let's go ahead and restore that ln. What if I wanted to also strip all white space from the line? Right? Because you might want to do that, say, I don't know, for the affine cipher. Right? There are a bunch of end-line characters. You want to read every single thing into memory and ignore all the white space in between the end-line characters. Maybe somebody indented and tabbed over or something like that. I've got a string here, line. How do I remove all the white space? What should I do? Google. String. Or Java string 13. There we go. It comes up. Documentation, read the documentation, RTM. Is there a way that I can remove stuff? Okay, well, there's no function called remove. So what's another, I'm searching for synonyms here. What's another way that I can say replace one character with another character? Maybe replace. Oh, hey. I can replace one character with another. So if I want to change all the lowercase h's to uppercase O's, I could do that. There's another version that you can use an entire character sequence. Replace HELLO with goodbye. Right? Or you can use what's called a regular expression. We're not going to get into regular expressions here, but I want to show you how powerful they are to encourage you to start reading some tutorials on them. By the way, plug, remember that there is an Initialize event. Initialize is a department student organization. This Saturday, they are hosting an event to teach people Git. There's a Git tutorial kind of a workshop that you can go to over in the Carson Center. I highly encourage you to get over there and learn Git if you haven't already. Or just go over there anyway and help other people who are trying to learn Git. Or they might, it's a 3-hour event, so they might have some food there. I don't know. Don't quote me on that. But you can go there and you can learn Git a lot deeper than you may have in class. Right? In class, we've just had you use it to clone stuff from a GitHub repo. In your first assignments last semester, you were committing stuff and pushing it to your own repo, collaborating with somebody else. There's a whole bunch of other stuff that you can do, though. Right? Regular expressions, I would put in that same toolbox. Make sure that you are are aware of them. You don't have to necessarily learn them at a deep level right away. I don't know them at a deep level. I just know that, okay, I could do that with a regular expression. Now the details, I'm going to have to look that up in some documentation. Remind myself, what is the regular expression for all white space? Right? I do know that off the top of my head. Dot replace all. Right? I want to replace all white space with nothing. I want to remove all the white space. Now, this is not a regular expression here. I just did that for plain English. The escape sequence in Java for white space is /s. Right? Don't ask me why. In some regular expressions, I think it's like /w, which would make sense, white space. Some of them I think is /b or something. But this is going to complain. Why? What happens if you want a backslash in your strings? You need to escape it. So I need 2 backslashes. And by the way, if you had a regular expression with 2 backslashes, you would need 4 backslashes. Right? Now this is just one white space character. What I'm going to do is I'm going to put a plus at the end. The plus is an indicator of one or more, or instead of, if it were a star, that'd be 0 or more characters. I want 1 or more white space character because if in my line I've got, say, 5 spaces there, or maybe a tab. I am tabbing over here. There's a tab there. Maybe there's a whole bunch of n-line character. You can't have n-line character, more than one n-line character on a line. But maybe I've got a bunch of other blanks. Right? What I'm going to do is I'm going to read this line by line, replace all instances of white space with nothing. And you'll see what it looks like after I save it and run it. There we go. And all of that white space in the first line, second line, blank above, the last line was stripped out. There's nothing in this line because the string ends up being empty. And when I print it out, I'm still printing out that unline character. Extremely powerful. You can write a regular expression to match any, say, email address. That's a little bit hairy. Anything that looks like a telephone number. Anything that looks like an international telephone number, and then you can distinguish between those. anything that looks like a URL, right? And you can do some extremely powerful stuff with very simple regular expressions, okay? So something to put in your toolbox and look up can I do that with a regular expression? Look it up and see how to do it, and you'll start building up that toolbox and that knowledge for yourself. Right? All right, that's stripping all the white space. That's 1, 2, and 3. 3 should be what, though? When you're done processing a file, what should you do with it? Close it. Right? So s dot close. Right? I'm closing the scanner, by the way. I'm not closing the file. File is just like kind of a metadata class. It says that there is this thing with this path and stuff. It's not actually opening it. The scanner is what opens it. And I close it down here. Okay? That's file input. What about file output? Okay. There are lots of ways of doing this. I'm only going to show you one, and I'm only going to show you the one that's easiest. So I'm going to go ahead and try and then catch. I think catch file not found exception. Yeah. Oops. All right, everything's screwed up. So format, awesome. It did it automatically for me. And it's complaining about this because I've not done anything to actually throw a file not found exception. Let's go ahead and do that now. File or output is equal to new file. And let's go ahead and put it in the same directory so we can check it out. Data/output.txt. There we go. And then what I'm going to do is I'm going to use something called a Printwriter, right? PW. New Printwriter for that output file. Printwriter is basically this nice little wrapper that wraps everything up, and I believe it uses some buffering so that when it outputs stuff to a file, then it's done in a buffer so that it's not outputting every single character at the same time. File I/O is extremely expensive because writing to disk is extremely expensive, especially if you've got an old school hard drive. Like I think I don't know what I have in here. I think I've just got an old school mechanical drive right here. What's better than that? SSD. What's better than that? Yeah, there we go. Yeah, good. Get rid of that SATA cable, right? It's the bubblegum ones, that you plug directly into the motherboard. How much faster are they? All right. Well, I thought that they were up to 20 times faster, and then we were debating it, and it's so really expensive. No way. I saw some 970s for a half a terabyte, $90 or something on Amazon. M2, right? NMV, M.2, NMV, NV, or whatever. Search. It looks like a strip of bubble gum, and then it's a whole hard drive. So for immediate boots, basically, right? You can put your computer to sleep, and immediately it boots up. So there's Printwriter, buffering, right? Buffering is one way of dealing with that stuff. Don't write every single character to the hard drive. Wait until you have 1,000 characters, and then dump them all at once, right? Because it's expensive. Well, why do I show you Printwriter? Because it's the simplest, easiest way of doing stuff. pw.println. Hello, this is the first line. Right, that's it. You're printing to a file now. pw.print. Another line. Put in your own end line character. There we go. Why? What's the difference? Println, system.out.println, system.out.print. System.out. What was the other one? Printf. Right? Everything is familiar again. %d, %f, I don't know, 10.2f. There we go. And 123, and then math.py. Right? Once you're done doing some output, what can you do? Close. Right? And now there is something with I would be somebody's probably going to complain on the internet or whatever that you didn't cover try with resources. There is something called try with resources where you don't have to close this stuff anymore. It does it automatically for you. Go ahead and look it up. It is mentioned in the notes or the book. Right? I'm not going to cover it though because we can't cover every single aspect of Java. Let's just run this and make sure that it actually works though. Oh, great! It ran. No errors, no exceptions, no red text. I don't see a file over here. Start panicking. This is just your IDE, and this is just Eclipse giving you a quirk. Sometimes your file system and the IDE fall out of sync. If you dragged and dropped a file manually to a directory somewhere in your project, then your IDE doesn't necessarily, Eclipse doesn't necessarily know about it. Let's force it to know about it by refreshing. Right? Usually the first thing, something's wrong, hit refresh, then hit rebuild. Right? Refresh is one thing that you can do. Oh, it magically showed up there. It was there the entire time. It's just that it wasn't showing up in the file explorer here. Let's go ahead and look at it. Hello, this is the first line, another line, put in your own inline character, 123, and then 10 blank space, or 10 spaces, let's say, I guess it would be 6 spaces, and then 3.14. There's an output file. Okay. I'll make sure that you have all this in the notes. File IO. As an example, just make sure that you close your stuff. All right, questions so far? We're not going to have enough. What I want to do now is I want to bring together everything that we've covered up to this point and do an actual exercise. There's still some stuff to cover, including searching and sorting, classes and stuff like that. I'll save that for next week. We're not going to be able to get this done today, but we'll get as far as we can. So the exercise that I want to do is, some of you are familiar with it. It is protein translation. Many of you did, if you took 155E last semester, you did something like this, where you're given a bunch of DNA. For example, you're given AAA, TC, adenine, guanine, thymine, and cytosine. Thank you. All right, those 4 things, right? What you do is you need to cut it up into trigrams. UAA or UAG or whatever, AAA, TTC, CGC, etc. You cut it up into trigrams, and then you first you translate it to RNA. RNA, the only thing that happens is what? I have to remind myself. Adenine is changed into uracil, is it? Thymine is okay. So T's become U's, right? That's all that we really care about. Now, somebody did ask, here we go, by replacing each thymine nucleotide with a uracil. All right. So I don't know much about biology. I tried to find a biologist to clarify this. DNA is a double helix. So for every A, you have whatever the complementary nucleotide is, GGG or something like that. The way that it actually happens is it gets, the double helix is taken apart, and only one of these strips is used. So which one is translated into uracil? Don't worry about it, right? Apparently there are codons on the DNA strip itself that says use that one or use that one. I didn't want to get into that level of detail. So we're going to read in from a file a bunch of DNA. Then we're going to translate it to RNA by simply replacing all thymines with uracils. Then once we've done that, we're going to use a mapping that AAA maps to this protein over here. I have no idea what K stands for. But AAA, that trigram, that gets translated into K. Another example here, GGG or GGA would get translated into the protein G. Right? I've got an entire mapping here from last semester. We gave that code to you. We're going to write that code this time. Okay? So what I want to do is I want to process a protein file. So part 1, read in the contents of a file containing DNA. So I don't have one. Let me go ahead and go over here, new file, DNA.txt, DNA.txt, Dan's DNA. All right. And I don't have an example either, so what I'm going to do is I'm just going to steal this. Oh, I can't. I can't highlight in GitHub. So let me go ahead and just go with AAA, GGA, C, whatever. 123, 123, TTT, GATK. There we go. And AA to round it all out. And you know what? I'm going to break it apart on multiple different ones here, and then maybe change some stuff here. TTC, not Z, A, G, T. All right, so a bunch of different DNA, different links, et cetera, et cetera. This is a DNA file, right? I want to now process that file. So that's what we just covered. How do I do file input? A scanner. And I want to read from a new file called dna.txt. Actually, where is it? It's in that data folder. So where do I need to read it from? Data/dna.txt. It's going to complain about it because I need to surround it with a try-catch, catch and release. So by throwing a new runtime exception, E, or just rethrow E, but then it won't be it'll still be a checked exception. There we go. Okay. So I've opened up the file. Let me go ahead and read it line by line like we did before. While s.has next line. There we go. String line is equal to s dot next line. How do I process it? This DNA string could be on multiple lines, just like your affine cipher is on multiple lines. Let's worry about formatting later on. Let's just go ahead and take everything and concatenate it together. Right? Let me go ahead and create a string DNA. An empty string initially. Once I've read this line, I'll go ahead and say that DNA is equal to DNA concatenated with line. Right? All I'm doing is reading an entire line and concatenating it to the end, to the end, to the end, to the end. So that at the end of the day, I need to close, s.close, right? System.out.println. Let's make sure that it's actually working. Oh, wait, poor man's debugger. Or not S, but DNA. There we go. Let's make sure that we read everything in. And it looks like we did, right? There are no holes in it. Why did it work? Well, because it was chomping out those end-line characters. What if I have a bunch of, here, tab, or not, backtick, tab, and then a bunch of other holes in this DNA, right? Then those are going to show up down here. How can I get rid of those and strip those out so that I'm assured that I only have DNA instead of white space? Before I print it, I'll go ahead and go with DNA is equal to DNA dot replace all white space with nothing. And now I can print it out and see, oh, okay, that works. Right? Poor man's debugger. Don't use the standard output. I want to know, am I okay up to this point? Set a breakpoint. Run the debugger. Yes, switch. Right. What is the DNA at this point? Well, there it is. And if I go on to the next line, what is it now? Well, that's what it looks like. Don't pollute your code with a bunch of system.outs that you then comment and uncomment. That's getting into a bad practice because eventually you'll leave some of those in there or you'll leave dead code in there. Once you learn how to use a debugger properly, you'll never go back, right? So use a debugger. Don't use print.out, system.out.print. Yeah?
You did say that there is also a next char.
Yeah, I don't know that there's a next char, s.next byte.
Oh, okay.
Yeah, there's no next. There's a next string, so s.next. That'll give you the next string. Oh, it has next, just next. That'll give you the next string, and the way that it does that is it goes by white space. So it'll give you the entire string up until the next white space. So you could do that too instead of stripping it all out like I did here. Right?
That's in the input-output library?
It's all part of scanner. So
scanner.
Java, scanner. Tell me all about that. And, well, you'll get Java 7 here, but a whole bunch of things that you can do. In fact, a very nice documentation here on how it all works. Right? So now that I got my DNA, what was the next thing I need to do? I need to translate thiamine, T's, into uracil, U's. Is there a way that I can replace everything? DNA dot. I could replace all T's with S's. Right. But if it's just a single character, then I can also use replace, and then it's a single character. Replace all those characters with, oh, not S, but uracil. There we go. There we go. Okay. Let's go ahead and see what. I've already got the old breakpoint. Let's go ahead and run it and see if it works. Yeah, switch over to that perspective. Run over that, and it takes care of all the white space. All the white space is gone. Let's see if all those T's were now translated to U's. No. What did it do? No, I'm not printing it. Right. Ah, good catch. So remind me, tell me about strings. Can you change a string? Nope, they are immutable. Replace, if you hover over this, returns a new string that you have to capture into a variable, because you can't change the old string. Produce a new string and then make DNA the reference point to that new string. Right? So keep that in mind. Now that I've replaced that all, let's go ahead and run it again. So step, and look at it. All those T's are now U's. Excellent. What's next? Now I need to go through and take trigrams. Right? So, how could I do that? Oops, I need to stop it. Stop. I could split some DNA.split. If you were going to split it on a delimiter, like a comma, like CSV data, right? You could do that, something like that. But that's not what I want to do. I want to take the first three, then the second three, then the three, three. Right? It's kind of like a length split. I think you might have done that last semester. Right? Well, let's just write a loop to do it. For int I equals 0, I is less than DNA. How do I get the length of a string? Length? Okay. I plus plus. Now, this first iteration here, this first loop here that I'm going to show you is going to go for each character, right? So char c is equal to DNA dot. How do I get a character at a particular index? Char at the ith index. And then let me go ahead and print them out and show you that this is actually processing it character by character. Right? There it is. Right? So AA, GG, and then all those T's have become U's. Right? So, but that's not what I want. I want 3 characters. Okay. I could go C1, C2, and C3. And then I could create another string, trigram, is equal to C1 plus C2 plus C3. That's not going to work. Why? I thought you could concatenate anything. What is a character in C? It's basically a number, right? Capital A would be 65 because of the ASCII text table. Same thing here. It's not going to allow you to, if you did this in C, it would work, but it would get you some incomprehensible stuff. It would be like, if I had 3 A's, it would be 65 plus 65 plus 65, which doesn't make any sense in the character system. Right? So, okay, fine. Back to school. Besides, is it nice to have 3 variables just to do? Oh, not I, but I plus 1, and then I plus 2, and then instead of going by 1 each time, I can go by 3s. Right? Okay, that's still kind of icky though. Right? What do you really want? I want the first 3 characters. I want the second 3 characters. I want the third 3 characters. What is this? Just one of those characters is it's a string that's part of a larger string. It's a substring. I wonder, Java string, is there something in the string library that will help me call for substrings? Oh, hey, substring. I think we covered that already, but reminder, always read the documentation. Is there something there that will solve my problem for me? Substring at a beginning index all the way to an ending index. So if I get a string trigram is equal to DNA dot substring of I and then I plus 3, 3 over, that'll get me this trigram. Again, don't do poor man's debugging. Let's do proper debugging here and check it out and see if it works. Next. All right. Here's my DNA. It should be AAA, then GGA. So step into this. I is, you can even see the index variable over here, I. Step over it. Oh, darn it. Okay, step into. No. One bad thing about this is, okay, no, I don't want to, now I'm down the rabbit hole. I actually stepped into the Java standard library here. Length, right? If you want to know how a string is actually implemented in Java, here's all the code, right? You can go ahead and take a look at the inner workings of this stuff. If you're interested, don't, only if you're very interested in it, right? System.out. Okay, I'll go ahead and revert to poor man's debugging here. The only reason I'm reverting here is that we don't have any other lines to stop on and actually read it. Terminate. All right, there we go. And let's go ahead and print these out and make sure that we get them all. AAA, GGA. I assume that was correct. And the last one is AAA. Is that right? Last one is AAA. Okay. So now I've got my trigrams. You know what? Okay, copy, pasta. There's my, there's all the data that I need, right? That if I've got this string, AAA, it should map to this thing over here. Right? But I just copied that from C. In C, this was an array. It was actually an array of arrays. It was a two-dimensional array. What would be a more appropriate tool here to use in Java? A map that maps a string to a character. Right? So, with only 3 minutes to go here, let me go ahead and create a map that maps a string to a character. Remember that you can't use char because you can't have primitive types there. So let's go ahead and go back. DNA or RNA to protein. All right, there we go. Is equal to new hash map. Just the star operator is enough there. So now I've got that map. And what I want to do is I want to put each one of these things into a map. So don't mind me. I'm going to just sit here and type for the next hour. RNA.protein.put. That string is going to map to that character, and I need to end the line. Right? RNA.put. Okay, copy, paste. Oops, screwed up. Copy, paste. Don't mind me. Can anybody tell me if there's a better way, though? Block edit. Don't copy paste. Well, do copy paste eventually, but do it all at once. There we go. And of course, it's still not compiling because I need to take care of the other end here. That I need to change this stuff to that stuff. Right? And instead of, are we doing all right? Yeah, okay. There's other issues here, but you know what? Okay, I don't know about block encoding. Here's the last trick of the day that I'm going to show you. Find and replace. Find any instance of a space, curly bracket, comma, and replace it with parenthesis, semicolon, replace all of those. Now, that might have screwed something else up. No, it didn't. We're still good on that. But it's still not compiling. Why? Last question of the day. Why is it not compiling? Can I just put code anywhere? No. Where does code belong? It belongs in a class. It's in a class. Executable code belongs in a function, right? Or a method, right? So how can I put this into a method and design this so that I can get this kind of map here? We'll cover that on Tuesday.